In this section, let's focus on a very important platform for MLOps engineers, that is Kserve. So we will learn what is Kserve, why Kserve, how Kserve helps MLOps engineers, and also we will perform a demonstration using Kserve. Because this is the very first lecture of this section, let's focus on the fundamentals of Kserve. Let's get started. So let's quickly go back to the machine learning lifecycle. We all know data scientists within the organization, they work on preparing the models. So typically, data scientists get the business requirement. According to the business requirement, they prepare a data set, they choose an algorithm, and they constantly train the algorithm on the data set. And the output of this training process is machine learning models. And these models are stored in .pkl format, joblib format. It depends on the framework that data scientists choose. So by this point, model is prepared, model is saved, but the job is only 50% done for the organizations. Why? Although the model is created, model is stored on the local machine of data scientists or stored in a centralized registry. But model is not served to the end users. This is where MLOps engineers come into picture, and MLOps engineers implement model deployment, they implement model serving, and also they help with model inference. Inference is nothing but when end users make a request to the API of the model, model returns the prediction. So this stage is called as inference. Now these activities take a lot of time even once the model is prepared. Now, how about a platform that can help MLOps engineers automate most of these activities? That would be absolutely perfect. That would be absolutely great. And that platform is Kserve. So Kserve is an open source platform, and it is completely based on Kubernetes that can help MLOps engineers with model deployment, model serving, and also model inference. Now you might have a question, but Abhishek, we did these stages or we implemented these stages even in the previous sections. For example, we implemented these stages on virtual machines in one section and on Kubernetes in another section. So why do we need a platform? Why MLOps engineers have to use a platform? Now, if you observe carefully, although we implemented these steps, there were multiple manual activities that we performed. For example, to deploy the models onto the virtual machine, once the models are created, the first thing is ML engineers had to create the Flask API for the model. They had to write a Python script. And once the Flask API is created, MLOps engineers had to implement WSGI. They had to implement Nginx reverse proxy. On top of that, MLOps engineers should create the required infrastructure on AWS. MLOps engineers should deploy this model onto the infrastructure, implement auto scaling, implement load balancing, create networking, lot of manual activities. And these activities can typically take days of time as well. Or maybe it can take 2 to 3 days as well. In the same way, even when the model deployment and model serving is performed on Kubernetes in the previous section. So in the same way, once the model is created, the ML engineers should create Flask API. And once the Flask API is created, the MLOps engineer should implement WSGI, then should create containers in this case. Once the containers are created, MLOps engineer should create the deployment manifest. They have to create the service manifest, implement auto scaling on Kubernetes, maybe using HPA, VPA, and also MLOps engineers have to implement load balancing and other networking configuration. Even in this case, this can take a lot of time for model deployment, serving, and inference. Now, these manual activities, if not completely eliminated, they can be eliminated to the good extent using Kserve platform. Once again, Kserve is a complete open source platform and it is based on Kubernetes, which makes the model deployment, serving, and inference easy for MLOps engineers. When we implement the demo, you will realize all that MLOps engineers have to do, they have to take this model file. They can provide the location of the model file, maybe in S3 bucket, in GCS bucket, any centralized location. Once they provide the location to the Kserve platform automates all of these activities. So it typically takes 2 through 3 steps for MLOps engineers to get the model from the local machine to production. Now, is it all what Kserve is capable of? Not really. There are other advantages of Kserve. For example, one of the major advantages, according to me, Kserve supports different frameworks. In the previous sections, we learned how to implement model deployment and serving for scikit-learn related models. That is, in all of our previous sections, we dealt with .pkl file models, right? Everything that we saw, data scientists wrote those scripts using the scikit-learn framework, and ML engineers created the API using Flask. So the output is .pkl file. So we learned how to implement the deployment and serving for this format, but data scientists can choose different frameworks as well. For example, some data scientists might go with TensorFlow. Some data scientists might choose a different framework. They can choose, let's say, XGBoost. I think we saw an example with XGBoost as well. Or they can choose frameworks like PyTorch. Now, as the frameworks change, the model file output, or let's say, instead of .pkl file, this time, because they choose a different framework, if they choose TensorFlow, the model is created in the TensorFlow file format. Just like how developers, if developers choose a different programming language, DevOps engineer steps also change, right? Let's say developers are using Java framework, then DevOps engineers should learn Maven. They should learn maybe Gradle. And if DevOps engineers use, let's say, Golang, then they have to learn about the go.mod file, go.sum file. If DevOps engineers choose, or if developers choose JavaScript, again, they should learn about NPM. They should learn how to deploy NPM packages, CI/CD for NPM packages. Same is with MLOps engineers as well. So because the learning curve is steep, Kserve-like platforms can help MLOps engineers because Kserve works for all of these frameworks. Now, it doesn't matter in which framework data scientists created the model, just provide the location of the model. You can, as I told you, you can put it in any centralized location. Just provide it with the location with the Kserve CRD. I'll show you in the demo. And it will implement end-to-end tasks. This is the best part, right? So the learning curve for MLOps engineers becomes less. Of course, one thing I can tell you, mostly scikit-learn is used. It is a very popular framework and we learned the implementation for scikit-learn. Now, apart from this, the other advantage that Kserve platform brings onto the table is auto-scaling. Imagine in the previous section when we learned about model deployment and serving on Kubernetes, we did not deal with auto-scaling. But if we had to deal with auto-scaling, then we have to implement things like HPA, we have to implement things like VPA, or we have to manually configure KIDA or Knative, right? We have to deal with such cases. Or maybe we should go with platforms like Carpenter. When you go with Kserve, because it is based on Kubernetes, and it can automatically take care of scaling as well. And it can take care of scaling in regular approach, and also it can take care of scaling in serverless approach as well. So it can turn down your pods to 0, and when required, it can bring your pods to 10 as well or 20 as well. Everything is performed automatically using Kserve. So it uses Knative under the hood. Of course, it also supports KIDA. So finally, right, before we conclude this lecture, let me do a very quick recap. Kserve is an open source Kubernetes based platform that helps MLOps engineers with model deployment, serving, and inference. Without this platform, MLOps engineers have to implement a lot of steps, such as creating web server gateway interface, Nginx reverse proxy, infrastructure, creating the virtual machines, setting up auto scaling, load balancing. But with Kserve, all of these activities can be automated. On top of that, Kserve supports multiple frameworks. Whether data scientists use scikit-learn, they use TensorFlow, XGBoost, PyTorch, MLOps engineers can just provide the location of the model file, and Kserve takes care of the deployment and serving. Kserve can also help with auto scaling. So because it's a Kubernetes native platform, it helps the auto scaling with Knative as well as KIDA. It supports both of them. Otherwise, MLOps engineers should manually implement HPA, VPA, KIDA, or Knative. So this is about Kserve. In the next lecture, let's dig a little deeper into Kserve. But I hope this lecture is clear and documentation is provided in the GitHub repository. Make sure you go through it before we go to the next lecture. In the previous lecture, we learned what is Kserve. In this lecture, let's focus on the Kserve architecture. This is very important to understand. Once you understand the architecture, installing it, implementing Kserve becomes quite easy. And I'll make sure to explain this to you with an example so that you will never forget the Kserve architecture. Let's get started. So let me take an example. Imagine a company like Netflix. We all know Netflix has a recommendation engine. You know, as soon as you log into Netflix, you see bunch of recommended movies that is actually from their recommendation engine, which is set of machine learning models. Now let's say Netflix decided to implement Kserve so that as soon as data scientists within their organization, once they create the recommendation models, they are shipped to the production faster. So they took the decision. Now it's MLOps engineers' turn to first set up a Kubernetes cluster. Let's say they already have a Kubernetes cluster. MLOps engineers can reuse the cluster. In fact, MLOps engineers can share the same cluster with DevOps engineers as well. Okay. Once the Kubernetes cluster is created, MLOps engineers create a namespace, something like Kserve namespace. And within this namespace, MLOps engineers create the Kserve controller. Just like how DevOps engineers create Argo CD controller, Istio controller, Prometheus controller. In the same way, MLOps engineers create Kserve controller, which is open source. They use Helm chart or they use manifest and create this controller. Now, what does this controller do? Once this is set up, this is a cluster scoped resource. That means it is capable of watching all the namespaces within the cluster. Let's say this cluster has two namespaces. One is the recommendation service namespace, which is used by recommendation team. And let's say there is another namespace, payments, used by the Netflix payments team. Now the dedicated MLOps engineer of the recommendation service namespace or the team creates something called as inference service. Now what is this inference service? This is a custom resource definition provided by the Kserve project itself. So this is a custom resource definition, and using this custom resource definition, the dedicated MLOps engineer provides the information of where the model is stored. Right? By this point, data scientists must have created the model and stored the model in a centralized registry. So using the CRD, the dedicated MLOps engineer provides the location of the model file. And this CRD, as soon as it is created, this is watched by the Kserve controller. Now this will watch the controller, this will understand the model location, and instantly it creates HPA. Basically, it creates a deployment with horizontal pod autoscaler. And this deployment will create the pod. You all know the pod has the model container. So in a nutshell, Kserve controller watches inference CRD, whoever creates the inference CRD in whichever namespace. It can be the recommendation namespace, it can be the payments namespace, or it can be in the XYZ namespace. This controller is capable of watching all the namespaces. It reads the model location for the CRD or custom resource, and it will create deployment with horizontal pod autoscaler. And this deployment will create a pod in which the model container is running. Now it doesn't stop here. Once it creates the pod, along with that, it also creates a service for the pod, and it creates ingress resource as well. The best part is that Kserve is also capable of gateway API. So if you want, it can create an ingress resource for you, or if you want, it can create gateway API for you. It's just a parameter that you have to provide. When you are installing the Kserve controller using Helm chart, you can just provide the information in the values.yaml. Do you want to go with ingress or do you want to go with gateway API? And it will create the similar resource for you. Now, once the ingress is created, you all know what happens. Now, end users, they can access the ingress URL, and from the ingress URL, they can send the request to the pod where the model container is running. Now, model container, as you know, and as we learned in the previous lecture, Kserve supports different frameworks. So it doesn't matter if your model file is a PKL file, job web file, or any file, it has model servers compatible. So the model container is running within the pod and it is running actively. So this is the end-to-end workflow. Once again, I'll quickly repeat this. So basically, the MLOps engineer's job is very, very simple. They either have to create a new Kubernetes cluster or they have to use the existing one. And within the cluster, they have to create a namespace for Kserve. And within the namespace, they have to create Kserve controller namespace. Abhishek, where can I get this information? Because this is open source, you can get it from the open source docs, or you can also get it from our GitHub repository. So it is typically a Helm chart. So by running the Helm chart, controller is created and it doesn't sit in the idle state. As soon as it is created, it will watch for the resources. So if a dedicated MLOps engineer of a particular team, if they create something called inference service custom resource, it is watched and the controller creates deployment with horizontal pod autoscaler, and that in returns creates a pod which has the model container running. Along with that, it is also capable of creating service plus ingress or service plus gateway API. And through the ingress or gateway API, end users can access the model container. This is the end-to-end workflow. In the next lecture, now that we understood the architecture, we will implement the demo. Perfect. So in this lecture, let's focus on the demo. Let's understand how to install Kserve on a Kubernetes cluster, how to configure it, and how Kserve watches for inference service CR, the custom resource, and how it performs model deployment as well as serving. Let's learn all of that step by step in action. So we will first start with creating a Kubernetes cluster, because as we learned, Kserve is an open source platform based on Kubernetes. Now in the previous sections, we implemented deployment and serving on a remote Kubernetes cluster. So this time, to also save costs, let's use a demo Kubernetes cluster. That's a local one. I'll use Kind for the demo. Of course, you need to have Kind already installed. Along with that, you should also have Helm as well as kubectl installed for this demo. We already installed them in the previous sections, so I'll skip the installation part and directly head to creating the cluster. So I have Docker already up and running. So I'll just do kind create cluster -- name. Let me call the name of this cluster as MLOps Kserve demo. So this typically takes from 60 seconds to 2 minutes. And then we'll have our Kubernetes cluster ready. We'll go ahead and install Kserve. Perfect. So the cluster is ready, but make sure you perform a simple check, because a lot of times as DevOps or MLOps engineers, you deal with multiple clusters. So just check your kubectl is pointed to the right cluster. Kubectl config current context. Now, why is this important? Let's say you have a prod cluster and dev cluster. After creating the cluster, if your kubectl is pointing to the prod cluster, and unfortunately, if you have access to it, you will end up creating resources on the prod cluster. So always check this kubectl config current context. There you go. It's pointing to the right one. So I'll now proceed with the installation of Kserve. There is a prerequisite. You should first install Cert Manager. Now, why do you need Cert Manager? Because in real time, as we learned, Kserve performs model serving as well. And typically, you want your customers to access your model through HTTPS, but not HTTP. So you need SSL. And on Kubernetes, Cert Manager can take care of SSL for you. You don't have to create a self-signed certificate. You don't have to maintain it, manage it. Instead, just run this command and it will set up the Cert Manager. Now you don't have to worry about the commands. Everything is documented in the GitHub repo. So I'll share the GitHub repo. You can just follow the commands in the same way I'm executing. Going back. Okay, so let's have the Cert Manager installed. Now here is a catch. Cert Manager takes some time. So make sure you verify the pods of the Cert Manager are in the running state. Don't rush to the next steps before the Cert Manager pods are completely running. Because when we create the controller, it looks at the Cert Manager. Okay, we have most of the pods in running state. So let's go with the next step. That is to install the custom resource definition, right? Always before installing the controller, we should install CRDs. It's not only Kserve, but any controller that you are dealing with. It can be Istio, it can be Argo CD. First install the CRDs. So I'll create the Kserve namespace. Perfect. And I will install the custom resource definitions. There you go. Kserve CRD, the location of the CRDs, and also the version of the CRDs. Okay, so let's wait for CRDs to be installed. And once they are installed, let's go with the Kserve controller. Perfect. Again, I'll copy the command. Helm install Kserve. This time we are installing the controller. Now this again takes maybe 60 seconds to 2 minutes, because it's a Kubernetes controller it has to run as a pod and it has to move to the start state. Perfect. So Kserve control is also running. Now, what is the last step? If you remember the architecture, we created the Kubernetes cluster, we created the Kserve controller, we installed the dependencies. So going back to the architecture, now we are done with pretty much everything with respect to dependencies. Now, in one of the namespace, as MLOps engineer, we will install inference service custom resource. We already installed it CRD. Now let's install inference service CR in one of the namespace. So I'll create a namespace. Let's just call it as ML namespace. Okay. Going back to the terminal, kubectl, create namespace ML. As dedicated MLOps engineer within this namespace, I will create this inference service custom resource. Okay. Let me also explain you this, what exactly we are doing here. API version, kind, metadata. In the spec, you can see here, this is the location of the model. So it is stored in the Google storage and it is stored in the KF serving examples model sklearn 1.0 model. So basically they have bunch of models available just for demo purpose. I'm picking up one of their models, which is sklearn model. That's why you can see here the model format is also provided as sklearn. If you go to the documentation, you will find model format, let's say TensorFlow, and you will also find in this location some TensorFlow models. Similarly, MLflow models, right? PyTorch models. Let's execute this. So it says inference service sklearn iris is created. Now, as soon as this is created, if you go to kubectl get pods -n Kserve, you will notice this controller would have identified this custom resource. Let's check that. Kubectl logs followed by the pod name, and let's go with all containers -n Kserve. Okay, so you can see here reconciliation is implemented, and as part of reconciliation, see what it has done. Reconciling inference service. Which inference service? sklearn iris. So it identified there is a inference service created in the ML namespace. As part of that, it started creating the deployment. It started creating the service horizontal pod autoscaler. Whatever we learned in the theory part. Perfect. Now let's see. If I just do kubectl get svc -n ml, there you go. So I have the service ready. Because this is a local cluster, we cannot use it through ingress. What we will do is we will use port forward, kubectl port forward svc followed by name of the service, that is sklearn iris predictor, followed by port. Let me use 8080 as a local port, followed by the port 80. And let me also choose this address 0.0.0.0. If you are using virtual machine or something, this will be handy for you. Okay, I think I missed the namespace. Let me add it. kubectl -n ml. There you go. Perfect. Okay, so it says unable to listen on any requested port. Address is already in use. No problem. I'll change the port to 8089 and we are all set. Now I can access this model on port 8089. Let's verify. I'll take a new tab. Yeah, I'll duplicate the tab, keep the same locale, and here I will run this curl command. Again, the curl command, you can find it in the documentation itself. The curl command to access this model. So I am running curl -s on localhost Instead of 8080, let me change this to 8089. And this is the JSON data that we are providing to the iris model, basically for flower prediction. Enter, there you go. You see the prediction as 2. So it is flower species 2. So this is how Kserve can implement end-to-end things for you. All that MLOps engineer has to do. Imagine once the initial setup is done, Kubernetes cluster is ready, Kserve controller is ready, CRDs are ready, cert manager is ready. If all this initial setup is done, a newly onboarded namespace or newly onboarded project just has to create this inference service model. So they just have to run a single command. That's all. So they just have to provide the storage URI, requested resources such as the CPU and memory, all set. Kserve takes care of everything for them and their model is exposed to the external world, either through Ingress, Gateway API, or port forwarding. So I hope you found Kserve very interesting. So this demonstration is very short. And after watching this, make sure you go back, go to our GitHub repo and try the demo at your end as well. All right. Now let's implement model deployment and serving for our intent classifier model using Kserve. In fact, in the previous lecture, we implemented model deployment and serving, but that was for a sample model. Just like the previous sections, I have created a branch in the repository. So if you head to intent classifier model repo, along with virtual machines and Kubernetes branch, you will also find Kserve branch. So just head to this branch. You will find a file called implementation.md, and this will have all the commands that I'm going to execute. This is just to make your experience flawless. Perfect. So we will start right from scratch. That is, right from creating a Kubernetes cluster to deploying the model on it. It would take roughly 10 minutes to implement all the steps. Let's get started. First of all, I'll create a Kubernetes cluster. So let's take this as scenario. Some organization wants to onboard Kserve and they are completely new. They don't even have a Kubernetes cluster. Their requirement is very simple. They want to onboard our intent classifier model onto their Kubernetes cluster using Kserve. So for that, MLOps instance, that is us, we will first start with creating a Kubernetes cluster. So let's use kind create cluster -- name. Let me call this as Kserve demo intent. Now, if you want to try the same demo on EKS cluster or on an OpenShift cluster, it's up to you. You can definitely give it a try. There you go. So our cluster is created. Now, to install Kserve controller, there is a requirement. You need to have cert manager installed. We learned why in the previous lecture, because in real time, you want to have your model served on HTTPS. So you need certificates. Instead of creating the certs, maintaining them, rotating them, you can use cert manager. So let's install that. So this is a command to install cert manager. Once again, all the commands are in the repo. kubectl get pods -n cert manager. Okay, so all the pods seem to be in the running state, so that's fine. Let's go to the next step. That is, let's install CRDs for Kserve. Now to install the CRDs, first let's create the Kserve namespace. And here, using the helm command, let's install custom resource definitions. Typically, why you need to install CRDs before the actual controller? Because the actual controller might be using the objects, or it might be watching the objects that does not exist on your Kubernetes cluster. For example, Kserve will watch inference service. Now, let's say you run the controller, it cannot find the CRD, or it cannot find inference service custom resource definition. So that's why you should have the CRDs installed first. Okay, then let's install the Kserve controller. For that, I'll run this Helm command. Perfect. So now we will also have our Kserve controller running in some time. What are the next steps? Once we have the controller running, this is where for the individual project, that is for intent classifier model namespace, for the recommendations namespace, we will set up the inference service resource. Till now, what we executed is a one-time activity. Only this commands here. Only these are the ones that will be repeated for the projects. So once you perform the initial onboarding, steps are very, very simple. Whenever a new project comes into picture, just run these 3 commands for the project. Cool. So we will create this inference service, but in the inference service, there is a very important field, that is the storage URI. Where will you upload your model so that inference service or Kserve controller can download that model from you? In our case, model is a .pkl file. In the previous lecture, we downloaded it from Google Storage. We can also upload our PKL file to Google Storage, or we can upload it to S3 bucket. In fact, we can upload it to persistent volume as well. But I will follow a real-time approach that most companies would like to take. That is, they want to have their models, or they want to have their artifacts in the same GitHub repository where they have the source code. So that's why what I'll do in this lecture, I'll create a release binary. This is what happens in real time. Whenever a model is created, let's say through the CI/CD pipeline or CI/CD CT pipeline, the model is pushed as release binary to the GitHub repo. So we will head to the releases and we will manually publish the binary to this new release. So let's draft a new release. I'll call this as from the Kserve tag. Let me call this new release tag as 3.0. Okay. I'll name this as v3.0. And now if we scroll down, there is a section attach binaries by dropping them here. So we will drop our intent model.pkl file. But Abhishek, where did you get this intent model.pkl? If you remember, we already created PKL file for our model in the previous lectures. Let's say if you don't remember, it is very simple. All that you have to do is download our intent classifier model GitHub repo. I already have it downloaded. Many of you should also have it. Go to the folder, and in this folder, look for the models folder, CD model, and here look for artifacts folder, CD artifacts. Here you will find your intent model.pkl file. Let's say you don't find it, don't worry. You can create it in just a minute by running this command. So just head to the repository and create the dependencies, that is install the dependencies. First we need virtual environment, of course. So source.venv bin activate. Python 3 -m pip install -r requirements.txt. All the dependencies are already installed. That's why it took very less time. Now, once these dependencies are also installed, run this command python 3 model/train.py. In fact, we did this multiple times in this course, but I'm just repeating so that, even if you miss the previous lecture, you will find it easy. That's all. Once you run this command, you will have your model.pkl file in the model/artifacts folder. Now just upload that onto this GitHub repo and click on publish release. That's all. You will have your intent model.pkl, right click on it, copy link. Now go back to the implementation.md. So here in the Kserve branch, we will go back here and we will paste our location here. So change the downloadable location to the path. I'll just take a copy of it so that I can quickly paste it. Cool. So create the namespace first. Now that we got the location, go back to the cluster, kubectl, create namespace intent. Okay. Now I will run this command by changing the location. So the downloadable location should be changed to this one. I mean the new location. I copied it on the other tab. I'll just paste it here. That's all. Click on the enter. We should have our inference service created. In the meanwhile, you can also check the logs of your Kserve container. Let's see if it identified the inference service and if it started creating deployment, service, horizontal pod autoscaler. kubectl get pods -n kserve kubectl logs followed by this one, copy it, paste -n kserve. Okay, so it says something. Cool. So it identified, it started reconciling inference service. And here it already created the deployment service HPA using the reconcilers in the controller code. Okay, let's also quickly verify if they are actually created. If we do kubectl get horizontal pod autoscaler within -n, the namespace, what is the namespace? Intent namespace. Horizontal pod autoscaler is created. Similarly, we will find deployment as well as service as well. If I do SVC, we have the intent service also created. Perfect. So now most of our job is complete because we already have the service. We just have to expose this service using port forward and we have to access it using the curl. Let's do the final steps. kubectl port forward, svc / copy, paste it. Let's expose port 8080. Okay, so the service port is 80 and the local port that I'm using is 8080. -n intent followed by address 0.0.0.0. So the port forwarding is also enabled. So let's go to the other tab and run the curl command. I pasted the curl command here. Okay, copy. What exactly is the curl command doing? It is sending the post request to localhost 8080 for the intent classifier predict endpoint. If you notice this carefully, you will find this little different. Intent classifier :predict. Usually it should be like this, but this is how Kserve implements the API. You have to use :predict. Okay, let's run this. There you go. So it says prediction is complete. You can also change it. Let me change this from I want to cancel my prediction to hello. And it says the prediction is greeting. So this is how you can implement model deployment and serving for any model. Imagine the steps that we performed is very, very simple. We just copied our model.pkl and store that in the GitHub registry. That's all, right? Everything else is taken care by Kserve once we run the inference service CRD or the custom resource. Now I want every one of you to go back and try this demonstration with our intent classifier model, because till now we perform virtual machine deployment, Kubernetes deployment. So it's time for you to also perform deployment and serving through Kserve so that you realize how easy it is and you can take this back to your organization. So this is all for today's lecture. Before we get to the next section, I want to talk about something very important related to Kserve. I know you all know Kserve is a useful platform for MLOps instance. Let me tell you, the same platform is also very widely used for LLM ops. Of course, at this point of time, I wouldn't encourage you to go ahead and try LLM ops. But if you learn this platform today, in future, you can use the same platform for LLM ops as well. Or in future, if you want to pursue the role of LLM ops, if you want to deal with large language models, this platform is going to be very handy in your resume. So that's why make sure you practice the demonstrations explained in the course. And if possible, you can take more models, probably the models that we covered in the previous sections or models available on the internet, and practice MLOps using Kserve. If you know MLOps using Kserve, learning LLM ops using Kserve is just a cakewalk, because almost the same steps to implement the LLM ops as well. Not only Kserve, most of the tools that we are learning in this section, in this particular course, are equally useful for LLM ops. It can be MLflow, it can be Kserve, or other platforms that we learned. Perfect. So I want to share this useful information in the lecture. In this